Welcome to day 5 of the high level design course, Software Requirements and System Understanding. Today we will dive into the crucial steps of collecting, analyzing, and translating requirements into actionable system designs. In today's session, we will explore the following topics: collecting and analyzing requirements, translating business requirements into technical ones, defining the system context, creating a functional decomposition, establishing a preliminary system architecture, and in iter- iterative refinement leading to final system specifications. Let's begin with the basics. What are software requirements? Requirements can be categorized into functional requirements, which specify the system's features or tasks, and non-functional requirements, which define how the system should perform, such as its speed, scalability, or reliability. To collect and analyze requirements effectively, stakeholder engagement is key. Methods such as interviews, surveys, and workshops allow us to gather diverse perspectives. Each approach offers unique advantages for understanding user needs and expectations. Functional requirements describe the specific tasks or actions a system must perform. For instance, allowing users to log in is a functional requirement. Non-functional requirements, on the other hand, focus on performance and constraints, such as the system should handle 1000 concurrent users. Both, both are critical for robust design. Eliciting requirements often involve tools like use cases, which detail system interactions, and user stories, which provide concise descriptions of functionality. Prototypes and mockups can also help by offering visual representation that stakeholders can evaluate. Once requirements are gathered, validation is essential. This involves engaging stakeholders to confirm the requirements meets their expectations. Techniques like traceability metrics can help link requirements to specific test cases. Additionally, prioritizing frameworks like Moscow, must have, should have, could have, and won't have help manage scope efficiently. Business requirements describe the problem, while technical requirements provide the solution. For example, a business requirement might state customers need faster checkouts, and its technical counterpart might specify implement a one-click payment system. Business rules such as defining pricing discounts or eligibility criteria must be translated into system logic. Similarly, constraints like budget or time limits need to be incorporated into the design to ensure feasibility. Mapping functional requirements involves breaking down high-level functionalities into technical components. For example, the requirement support multiple users translates into a technical solution like multi-user authentication. This ensures alignment between requirements and system design. Choosing the right technology is crucial. For instance, using Spring Boot for backend development and React for frontend can streamline the development process. The right tools ensure the system is both efficient and maintainable. Non-functional requirements often dic- dictate system performance and security. For example, to meet the requirement, system should respond within 2 seconds. We might implement database optimizations or caching strategies. Security requirements like data encryption guide decisions about authentication protocols. Scalability and maintainability are critical for system longevity. Scalability ensures the system can handle increased demand through horizontal or vertical scaling. Maintainability focuses on creating modular, clean, and extensible code for easier updates. Defining the system context means understanding its boundaries, what's in it in scope and what's out. This includes identifying external systems that the software will interact with and how those interactions will be managed. By defining boundaries, we determine what data will be processed within the system and what might be outsourced, such as payment processing. Additionally, we establish protocols for external communication like REST APIs or SOAP. Functional decomposition involves breaking the system into smaller, manageable modules. For example, an e-commerce system might have separate modules for user authentication, inventory management, and payment processing. Mapping data to use cases involves detailing the inputs and outputs for each system module. For instance, the authentication module might accept user credentials as input and return authentication results as output. Next, we establish a preliminary system architecture. This includes outlining key components and deciding on the architecture type, whether it's monolithic, microservices based, or service oriented. Design is rarely perfect in the first iteration. Iterative refinement allows us to incorporate feedback, improve prototypes, and adapt designs to changing requirements. Regular reviews ensure the design stays aligned with stakeholder needs. Finally, we consolidate everything into formal system specifications. This includes reviewing functional and non-functional requirements and documenting technical specifications in the form of an SRS, Software Requirements Specification. That concludes today's session on software requirements and system understanding. Remember, gathering and translating requirements is the foundation of a successful high-level design. Thank you for your attention.